This is your two-step inequality word problems lesson. So our I can statement is I can write and solve an inequality, find the solutions to a real-world situation. So you should hopefully have your guided notes page with you. It's a lot of word problems. So we set up the notes page for you to already have the word problems there for you, so you can focus more on what do I need to do in order to be able to write those problems in the form of an inequality and then to solve it. So first thing we want you to do is fill in the table at the top with a quick reminder of some vocabulary that are going to show up and kind of reminding you what do each of those terms mean. So we have the word sum or more than. Those are code for addition. They're telling you in a problem that you want to be adding the numbers together. If you see the word difference or less than, that's telling you that you're doing subtraction. But I want you to put this little double-headed arrow over less than. When you see just the words less than in a problem, it means subtraction. But less than is the only time where you're going to flip-flop the order of the numbers. Normally, if the problem says the difference of 8 and 12, you're going to do 8 minus 12. You leave it in that order. Less than is the only time where you're going to flip-flop the order. So if it says 8 less than x, we're going to rewrite it as x minus 8. So less than is where you're going to flip-flop it. So you want a little star next to that one. For multiplication, hopefully you're comfortable with the word product. That's a very common one. But then things like twice or triple. Twice just means 2 times your number. Triple means 3 times your number. It's code for multiplication, but they're being specific about what you're multiplying by. And then last we have division. The most common one is you're going to have quotient, or it might just say divide, but also things like half. Half means you're dividing something by 2. So sometimes it's hidden within the phrase or the word itself that it's telling you that you need to divide. So those are some that we want to watch for in the next couple problems. All right. We want to decipher these sentences in order to be able to write it as an inequality. So we kind of sort our way through and kind of look for things, and I like to kind of write it above or right below the sentence to kind of show me the pieces I need to use, and then I put it all together. So it says the sum, well, that means I'm going to add, of 3 times a number. When you see the phrase a number, well, we don't know what that number is, so that's where we put in our favorite variable. But in this case, I want to do 3 times that number. So 3x and 4. Well, there's my number 4. And it said I was finding the sum. So I want to add those two together. And then it says is less than. Remember, we talked about less than as kind of code for subtraction. But when that word is with it, that's really telling us this is where inequality goes. Normally is where the equal sign is. But in this case, it signals where the phrase is for our inequality. So we want less than. So we're going to put in our less than negative 62. So the sum, adding together, of 3 times a number, 3 times x, and 4, so plus 4, is less than negative 62. Let's try the next one. 9, that one's easy, less than. Notice it didn't say is less than, so we're not talking about our inequality, we're talking about our subtraction. But if you remember, we talked about this is where that little double-headed arrow goes, because it's really code for this is where the 2 pieces are going to get flip-flopped. So we'll come back to this in a moment. Then the rest of it says the quotient, well, that means we're going to divide, of a number, let's call it w, and negative 3. So that means we have w divided by negative 3. We have 9, and we want to subtract. But less than tells us that we want to flip-flop them. So instead of 9 minus w divided by negative 3, we're going to do w divided by negative 3 minus 9. Less than is that only time you're going to flip-flop this first piece, and it's going to become the second part. And then is at least. So we talked about this in an earlier video. The word at least means we want it to be 44. We're okay being equal to 44. Or greater than 44. At least 44 means 44 or bigger. So greater than or equal to 44. So just kind of piece by piece deciphering those pieces, and with some practice it becomes easier and easier. We're able to put all those together. So now let's try this in some word problems. And these aren't going to be quite as cut and dry because you're not going to have a lot of those same keywords. We're going to have to kind of think through how to set up the problem. But the easiest way I found to figure this out is instead of trying to find some unknown number, try plugging in an amount for one of these pieces and then see how you naturally would solve the problem. That leads me to how to set up the inequality in the first place. So this one says Tyler needs at least $205. Well, at least means greater than or equal to. So we know it has to be greater than or equal to $205. So we got that part ready. Now we got to figure out the part with the work going on. So $205 for a new video game system. He already saved $30. So he's got $30 and he earns $7 an hour at his job. Well, think about it. If he earned $7 an hour and I said he worked for 10 hours, what would you do? Well, you do 7 times 10 to figure out how much money he earned. Well, same thing here, except we don't know how many hours. We want to find out how many hours will he need to work, so we plug in our favorite variable. So let's call it h for hours. But the same idea. You were going to do 7 times 10 to find out how much you made for 10 hours. I want to do 7 times h to figure out how much you make for any number of hours. But we're going to add that to the money he already has. We're not going to get rid of that $30. We want to add it to whatever he makes at his job. But there's our inequality. $30 that he already saved plus $7 times the number of hours has to be greater than or equal to $205. He's got to have at least $205 in order to afford the new video game system. Now, we solve it. So we'll draw a line down. They added 30, so I'm going to subtract 30. Or you can think of it as adding a negative 30 if you're more comfortable with that. So 7h is greater than or equal to. In this case, if I subtract that away, I get 175. Divide both sides by 7, and h is greater than or equal to 25. 7 times 25 is 175. So when it says interpret or explain your answer, we want to know, do you actually know what this means? It's one thing to say h is greater than or equal to 25, but do you know what that actually means? H is how many hours. So it means Tyler has to work 25 hours or more, greater than or equal to, in order to make enough money. That's our interpretation. Do you really know what this number down here means? It means as long as he works 25 or more hours at his job, he will have earned enough to purchase that new video game system. So let's try another one. I'm going to read this whole thing, then we'll go back and kind of interpret it as we go. Mike's car needs major repairs. The mechanic said it will be $144 for parts, plus, well, that's nice, they come right out and tell us to add, $8 an hour to repair the car. How many hours can Mike afford to pay the mechanic if he can spend no more than $200? So let's focus on that last part, no more than. That means $200 is the maximum he can do. So he can be equal to $200, but he can't go over that, no more than. So that means he has to be less than or equal to $200. So we got that part set up. Now let's figure out how are we actually going to calculate how much money he can afford or how much money it's going to cost. Well, it said the mechanic said it's going to be $144 for parts. So we know he's got to pay that, plus $8 an hour to repair the car. Well, we want to know how many hours can he afford. So we don't know, so let's call that H, but we know it's going to be $8 per hour. So we're going to do 8 times the number of hours. So 144 for the parts, plus $8 for every hour that he works, but it's got to be less than or equal to 200. The most he can afford is $200. Now let's go ahead and solve it. Well, they added 144, so I'm going to subtract 144. That leaves me with 8 times the number of hours has to be less than or equal to $56, which luckily divides very nicely by my 8, and h is less than or equal to 7. So our interpretation says, well, h is less than or equal to 7. What does that mean? Well, h was the number of hours. So Mike can afford no more than, or you could say, or a maximum of 7 hours of repairs. There are some repairs out there for a car that can take even more than that if it's pretty significant. What we're saying here is, based on Mike's budget, he can afford no more than 7 hours of repairs. 7 was our answer. It can be less than 7 or it can be equal to 7, but it can't be any more than that. All right, last one. Talking about Anna in this one. Anna scored an 87 and a 91 on her first 2 math tests. If she wants an average of at least a 90 on her tests, what score does she need to earn on the 3rd math test? Well, let's go with that keyword here again, at least a 90. So we know it's going to have a 90 here. At least means she's okay being equal to 90, but she'd like it to be greater than 90. So at least means 90 or bigger, greater than or equal to 90. Now, this one's a little different. We need to find the average. So think about, how do you find the average of something? Well, you add together all of the amounts. So she had an 87, she had a 91, and she has a, I don't know. And then it gets divided by 3. Well, now we have an inequality that we can solve. So to find the average, we add them all up, divide by 3, and that gives us an answer. To solve it, we go backwards. So in this case, because the whole problem is over 3, we need to take care of the division first by multiplying times 3. Those 2 pieces cancel out, so I'm left with 87 plus 91 plus, I don't know, is greater than or equal to 270. Here I can combine some like terms. 87 and 91 is 178, plus x is less than or equal to 270. And then we subtract. Subtract 178 from both sides. And x is greater than or equal to, well, we can do a little borrowing here. For those of you who aren't comfortable doing it in your head. And we get a score of 92. So x is greater than or equal to 92. Again, can you really understand what that number means other than just plugging it in and kind of getting it out of your inequality? We were talking about what score Anna needs to earn. Sorry, that was a really bad straight line. I don't think straight even gets close to there. So what score Anna needs to earn on her 3rd test? So Anna needs a 92 or greater on her 3rd test. Sorry, I'm slow writing on this. In order to have an average of 90. So x is greater than or equal to 92, and that means a 92 or greater on our 3rd test in order to have an average of a 90. So again, think about how would you normally work through this problem if you knew all the information. Sorry, I cut off my x there. And that's how you want to set up your inequality, and then we just use our rules to solve it.